I'm your host, Dr. D. Welcome to Math in the House. Today, we're doing Math Analysis, Chapter 8, Section 2, Complex Numbers in Trigonometric Form. I'm your host, Dr. D. Okay, imagine with me for a moment a complex plane where we have real and imaginary numbers existing together. Here it is. Okay, what we have here is the horizontal axis is the real numbers. The vertical axis is the imaginary numbers. So if I go right 3, then I have real number 3. If I go up 2, I have imaginary number 2i. So that means the point that's right 3 up 2 is 3 plus 2i. If I go left 2 up 3, then I have negative 2 plus 3i. If I go left 4 down 1, then I'm at negative 4, negative 1. Negative 4 minus I. If I go right 5 down 3, then I have 5 minus 3i. So notice when I'm left, I've got the real being negative. When I go right, the real is positive. When I go up, the imaginary is positive. When I go down, the imaginary is negative. So it really is pretty simple. Now what happens if I'm right on the axes? So if I'm on the real axis on the right, then I have just plain real number, positive 3. If I'm straight up, then I have all imaginary, and it's positive, so that's 3i. If I'm left 3, then it's all real, but negative, negative 3. And if I'm down 3, it's all imaginary and negative. So right, left, real, up, down, imaginary. Piece of cake. All right. Now, let's take our triangle, and we'll put a triangle in the first quadrant of our complex plane. So what we have is some A distance right or left, some B distance up or down, and then we have a radius or a hypotenuse of this right triangle that's the distance from the origin to our point. And then that'll also give us a theta angle that goes to the point. So what we call rectangular form is A plus BI. A plus BI. That's rectangular. Now, trigonometric form is R times cosine theta plus I sine theta. Because notice the A, if I go cosine theta equals A over R, that means A equals R times cosine theta. So anytime you have an X value, it's R cosine theta. Now the Y value, or the B value here, is R sine theta. So I've got R cosine theta plus I sine theta, and it's I sine theta because the vertical is imaginary. Okay, now, we don't like writing cosine theta plus I sine theta, so we're just going to abbreviate it cis theta. r cis theta. And cis stands for cosine theta plus I sine theta. Okay, now, if I have a number in rectangular form and I want it in trigonometric form, then I find r by the Pythagorean theorem. So I just go a squared plus b squared, take square root of the whole thing, and that gives me r. Now, how do I get theta? Well, tangent theta is b over a. That means theta itself is the inverse tangent of b over a. So if you give me an a and a b, I can give you r and theta. Now, what if you have r and theta and you want a and b? Well, a is r cosine theta and b is r sine theta. Piece of cake. Okay, so cruising onward. What we want to do now is change these rectangular forms of complex numbers into trigonometric forms of complex numbers. So 4 plus 3i equals what in trigonometric form? Okay, let's check that out. So first thing, let's draw our triangle. So we've got the real here, the imaginary here. So 4 plus 3i means I'm going right 4 up 3. So 4 plus 3i, and here's my r, and here's my theta, of course. So, Pythagorean theorem, 3 squared plus 4 squared equals 5 squared. So that means r is 5. Now, I need theta. So let's just write this down here. R equals square root of 3 squared plus 4 squared, which equals square root of 25, which equals 5. Now, to get theta, we need our trusty calculator. Now, we want theta in terms of radians. So I make sure I'm in radian mode. And then I go inverse tangent of 3/4. I don't have to go 3 divided by 4. I know that's 0.75. And then just go inverse tangent, and bam, there it is, 0.6435 radians. So 0.64 radians. So I'm just going to go cis 0.64. That's it, piece of cake. Okay, now, what about 2 minus 2i? Well, let's do the same thing. 2 minus 2i. So I'm down here. 2i. Well, the hypotenuse, r, is going to equal the square root of 2 squared plus 2 squared, which equals 4 plus 4 is 8, so square root of 8, which equals 2 square root of 2. Now, anytime you have a 45, 45, 90 right triangle, which we know we have here, all you do is multiply either leg, which they're both the same, by the square root of 2. So there's our r, 2 square root of 2, cis. Now, what angle do we have? Well, we know this is the 45-degree angle, or the pi over 4 angle in the fourth quadrant. So that makes it 7 pi over 4. Bam, that's it, game over. Okay. Now, what if we go the other direction? We're given complex numbers in trig form, and we want to put them in rectangular form. Okay, so what I do is I go the other direction. R equals 5 here, and theta equals 7 pi over 6. So if I make my triangle then, I'm 5 out at 7 pi over 6. Well, 7 pi over 6 is pi over 6 past pi. So this is really what we used to call a 30-degree angle. So there's our 7 pi over 6, and this is 5. Well, since I have a 30, 60, 90 right triangle, that means the short side is always half the hypotenuse. So that makes that 2.5, or 5 halves. And then the long leg is the square root of 3 times the short side, so it's 5 square root of 3 over 2. But if you apply our formula here, that A, well, remember, A is here and B is here. So A equals R cosine theta, and B equals R sine theta. So what is cosine of this angle? It's negative square root of 3 over 2. So negative square root of 3 over 2 and what is sine of this angle is negative 1/2. So there's my A and B. So I make it A plus BI. So A plus BI. And notice it's left and down. Piece of cake. Okay, now, what about 3 cis inverse tangent of 2/5? Okay, same idea. What we're being given here is that the opposite and the adjacent are 2 and 5 respectively. So that means, so we have 2 and 5 here. So notice tangent of 2/5 is our angle right here. So we want the inverse tangent, and that's my angle. Well, what is my hypotenuse now? Well, 2 squared plus 5 squared is 29, so this becomes square root of 29. Now, this is going to be 3 cosine theta plus 3I sine theta. Well, what's cosine theta? 5 over square root of 29. So it's 3 times 5 over the square root of 29 plus 3I sine theta, opposite over hypotenuse, is 2 over square root of 29. So this equals 15 over the square root of 29 plus 6I times 1 over square root of 29. All right, so what we're going to do is just multiply by square root of 29 over square root of 29. So we have 15 square root of 29 over 29 plus, this is going to be 6 times square root of 29 over 29 times I. So once again, we have A plus BI. And all we did was found the R cosine theta, R sine theta, and bam, that's it. Okay, cruising onward. How about the quadrantal values? Okay, you want to make sure that you don't waste your time with cosine and I sine theta, because it's way simpler than that. The point at A is directly to the right, so that's all real, no imaginary. So let's say it's 3, 0 here, so that'd be 3 plus 0i, which is just plain 3. So 3 plus 0i in trig form is just 3 cis 0, because it's 0 radians this direction. Now what if we go straight up? Well, that's 0 real plus 3 imaginary is just plain 3i. Now, what angle is straight up? It's pi over 2. So all you have to do is go 3 cis pi over 2. Now what about negative 3 plus 0i? Well, that's just plain negative 3. That's just 3 cis pi, because pi is directly left. And if I want to go straight down, I have negative 3i, which is just 3 cis 3 pi over 2. So if you have positive real, it's cis 0. Positive imaginary is cis pi over 2. Negative real is cis pi, and negative imaginary is cis 3 pi over 2. So you don't have to do cosine plus I sine, you just remember what angle are we dealing with here. Okay, cruising onward. Now how about products and quotients of trig forms? That's where trig form is handy, because products and quotients are a lot simpler in trig form than they are in rectangular form. So notice the note here. Rectangular form is easy to add and subtract, but not as easy to multiply or divide. Trig form is easy to multiply or divide, but not as easy to add and subtract. Okay, let's see what we mean by that. So multiplying two numbers in trig form, you have r1 cis theta sub 1, so it's r cis theta of the first point, times r sub 2 cis theta sub 2, which is r cis theta of the second point. What do? Well, we just multiply the two radii together and add the two angles together. Piece of cake. Now what about division? Well, we're going to just divide the two radii and subtract the two angles. So that really is simple. All right, so let's check out a couple examples. Now z is any particular complex number in trig form. So we see z sub 1 is negative 2 square root of 3 plus 2i. Z sub 2 is 3 square root of 2 minus 3i square root of 2. And we want to multiply z1 and z2 and make the final answer rectangular form. Ooh, yeah, that just gives you a little tingle. Okay, so first thing we want to do is change z sub 1 into polar form, change z sub 2 into polar form, and then we'll be able to multiply them easily. So we're good at that now. We're absolute experts at that right now. So z sub 1 is basically 2 square root of 3 left and 2 up. So 2 square root of 3 left, 2 up. Now, what we notice is the long leg is square root of 3 times the short leg. So we know we have a 30, 60, 90 right triangle, and it's in the second quadrant, so we know that angle is 5 pi over 6. Well, that's handy. Next thing we know is the radius is the Pythagorean theorem, so it's square root of 2, square root of 2, square root of 3, add them up, take square root of the whole thing. Really, the simpler way to go is, I know it's got to be double the short leg, which is 4. So if we want to check that, though, we can square the 2, so r equals square root of a squared plus b squared, or b squared plus a squared. Now we're going to square the 2 square root of 3, and that's going to be 4 times 3 is 12. And so this equals the square root of 16, which equals 4. Okay, so basically what we just found out is z sub 1 equals 4 cis 5 pi over 6. Now let's do z sub 2. Z sub 2 is 3 square root of 2 minus 3 square root of 2i. 3 square root of 2 minus 3 square root of 2i. Now notice I have two legs that are the same length. That means the hypotenuse needs to be the square root of 2 times this, which 3 times square root of 2 times square root of 2 is 3 times 2, which is 6. Now, if we want to do that, again, we just go r equals square root of, square 3 square root of 2, and you get 9 times 2 is 18, plus another 18, so that's square root of 36, which equals 6. Now, what's the angle? Well, it's a 45, 45, 90 in the fourth quadrant, so we know that angle is 7 pi over 4. So we just found out then that z sub 2 is 6 cis 7 pi over 4. Now, z sub 1 times z sub 2 equals, well, we multiply the two radii, 4 times 6, which is 24, cis, add the two angles. Well, 5 pi over 6 and 7 pi over 4, we need common denominators. So we're going to make this 24th. So I multiply the bottom by 4, better multiply top by 4, 20 pi. And this becomes 6 cis, put 24 here, multiply the bottom by 6, better multiply the top by 6, so 42 pi. So I've got 20 pi plus 42 pi is 62 pi over 24. And that reduces to 31 pi over 12. Now, anytime I want to reduce an angle, I can take 2 pi off it. Well, in this case, 2 pi would be 24 pi over 12. So if I subtract 24 pi over 12, 31 minus 24 is 7. Okay, so there's my z1 times z2 in polar form. But note, we want it in rectangular form, so what we do is we change 24 cis 7 pi over 12 into rectangular form. So that's going to equal 24 cosine 7 pi over 12 plus, I will just make it like this, plus I sine 7 pi over 12. Okay, now we have to go to our trusty calculators, because 7 pi over 12 is not going to be a integer answer. Okay, so to change this into rectangular form, all I do is take the cosine of the angle, multiply by 24, take the sine of the angle, multiply it by 24. So I just go 7 pi over 12 take the cosine of that and multiply that by 24, and orange, enter, and I've got negative 6.211657. Okay, so negative 6.21. Now I just go to sine of 7 pi over 12. Multiply that by 24, and that turns out to be 23.18 I. So there's your final number. This is Z1 times Z2. So all we did was we took our first complex number, changed it to a trig form, take our second complex number, change it to trig form, multiply the two radii, add the two angles, and then we have our r cis theta. We simplify r cis theta, and then all we do is take the cosine of it, take the sine of it, multiply by r, bam, that's it. Okay, now let's do a division, and then we'll call it a section. Okay, so Z1 divided by Z2. So once again, we change Z1 into polar form. And notice it's negative 5i. So I don't mess around with r cosine theta plus I sine theta, all that junk. All I know is negative 5i is straight down. Well, what angle is straight down? That's 3 pi over 2. So it's 5 cis 3 pi over 2. And z sub 2 is, now, 1 minus square root of 3i. So we know that's going to go right 1 and down square root of 3. So we have our 30, 60, 90 right triangle. So I know my radius is 2, my angle is pi over 3 short of 2 pi, which is 5 pi over 3. So z sub 2 is going to be 2 cis 5 pi over 3. Okay, so z sub 1 over z sub 2 equals 5 divided by 2, which is 5 halves, cis 3 pi over 2 minus 5 pi over 3. Okay, now we have to change that to, or get common denominators, I should say. Okay, so we have 5 halves cis. Now, common denominator is going to be 6. So this becomes 9 pi over 6 minus 10 pi over 6, which equals 5 halves cis negative pi over 6. Now, I could change this to 5/2 cis 11 pi over 6, but we really know that's where it is anyway. So what I'm going to do is I'm just going to go to the negative pi over 6, and I know that's a 30, 60, 90 right triangle. So this becomes down 1 and right square root of 3, and here's my angle negative pi over 6, and this is a 2. So cosine of negative pi over 6 is square root of 3 over 2. So we'll just put this up here. Z1, Z2 equals 5/2 times cosine of negative pi over 6. So 5/2 times square root of 3 over 2 plus I sine. So 5/2 times, what's sine of this? Negative 1/2. So notice I've got the 5/2 times cosine of the angle plus 5/2 times sine of the angle. So that gives us 5 square root of 3 over 4 minus 5/4 I. Forgot the I there. Okay, so the real component is the right-left, which is 5 square root of 3 over 4, and the imaginary is down 5/4. That's it, piece of cake. Have fun with these.